Hi everyone. So this video will be all about converting a DFA to an NFA, converting an NFA to a DFA. Now, if an NFA is given in this format, like a transition table, or if it's given in a state diagram format, you could convert it to a transition table because this is the best way to convert it's the easiest way to convert the NFA to a DFA. If you have a state diagram given, convert it to first write the transition table format for that, and then we'll continue to the process of converting the NFA to the DFA. So from a state diagram, from a transition table, what we have to do is first we take the first line of the first state given. So these are a set of states. P and Q are there are originally four states. P is the starting state and S is the finishing state or the accepting state, and P goes to two states on input of 0. In NFA, it does not matter what it does not matter if there are two states of two alphabets or three alphabets, but it could what I mean to say is when there is one alphabet, which is 0, when there is one symbol or one input, that time it could go to two states. It could go to P itself or it could go to Q. So these are the set of states that it goes to on input 0, and it goes to 1 on input. It goes to P, it goes to itself on input 1. So this PQ is a set of states, but on a DFA it will be considered as one whole state. You could rename it to A if you want to, but it's better if we keep it this way. Alright, so first rewrite the first transition, which is P, from state P it goes to 0, it goes to PQ from 0 and goes to P on input 1. So PQ is one's whole state. In this table it's a set of states, but in this table, which is the DFA table, it's one state, which we could write as A, B, C, or whatever. So the new state will be P and Q here. So we take the state. This is a new state that we encountered. So we take the state and then we try to find out what happens on input 0 and input 1, where it goes. So let's look at this table. P and Q. The union of P and Q is on input 0. The union of P and Q is PQR. So PQR is one state, and on input 1, the union of P and Q is P and R. So P and R is one state. Again, these are the new states that we encountered, so we write them down here, PQR and PR, right? So, and then after that PQR, we again do the union operation. So P, Q, and R. So by unifying these states on input 0, we get P, Q, R, and S. So P, Q, R, S, and then on input 1 we get PR, and then this empty set. So we just write PR. So PR is another state. PR on input on the state in the state PR, when we do union operation on P and R, we get PQ and S. So PQS is one state, and PR on input 1 we get only P and empty state, so we get P. Now the new states we encounter are PQRS and PQS. Write them down immediately to keep track of the new states that you encounter in each step. So PQRS, let's do union on these states. So PQR and S. So we get PQR and S, and on input 1 we get PRS. So we jot down these new state that we encountered. PRS and PQS was encountered before. On PQS, on input 0, so PQS, on input 0, we do union on PQ, R, and S. So PQRS. And on input 1, we do PR and S. So we get PRS as one state. So PRS. Now we do union operation on P, R, and S. So PQ, S. So we encounter PQS. On input 1, on PRS, on input 1 we get PS. So PS is one state. So PS is the last state that we encountered. On PS, we do union operation on PQ and S. So we get PQS and PS. So no new states are encountered. All these states are on the left hand side of the column. So all of the states have been given and all of the transitions have been given on 0 and 1. Now this is the DFA that we encounter after this transition table. So from this transition table, we can convert this transition table into a state diagram. So these are the states P, PQ, PQR, PR, PQS, PS, PRS, and PQRS. Now notice in the transition table there are 4 stars, which means there are 4 accepting states. 1 starting state. Starting state is always 1, and accepting states can be more than 1. So in accepting states, how do we decide these are the accepting states? Because in the NFA table, in the NFA transition table, S was the accepting state. So whichever sets have whichever states have S in it, we denote them as the accepting states. So we have 4 accepting states. So let's look at the DFA. As you can see, DFA, one of the main criteria of a DFA is that all the input alphabets have to have a transition function. So at 1 it goes to P, at 0 it goes to 0, at 0 it goes to PQ, at 1 it goes to PR. Since there are 2 alphabets, two input symbols, 0 and 1. So for each state, all these transitions have to be given on the input 0 and on input 1. So we just draw the DFA accordingly, but from the transition table you could practice it, and you could just pause the video and see if your answer matches with the DFA given here. And so yeah, that's about it about subset construction, which is the conversion process of NFA to DFA. I hope you understood the concept of subset construction, how to convert an NFA to DFA. If an NFA state diagram is given, you first convert to a transition table, and if a transition table is given directly, you convert that to a DFA transition table, and then from the DFA transition table, you do in the DFA transition table, you always do the union operation from the NFA transition table, and then finally you draw the state diagram. So that's about it. I hope you understood the concepts, and